Welcome to Science Snippets Fun Facts and Trivia. Today, we bring you When Earth Froze Over in an Instant, the terrifying Snowball Earth era. Welcome to a time in Earth's history when our planet was completely encased in ice. A period known as the Snowball Earth. It's hard to imagine now, but there was a time when ice stretched from the poles to the equator, turning our world into a frozen wasteland. So, what exactly is Snowball Earth? The term refers to a theory suggesting that Earth was covered almost entirely by ice during several periods in the distant past, possibly over 600 million years ago. These periods were some of the most extreme glaciations the planet has ever experienced, with glaciers covering the oceans, continents, and just about every inch of the surface. Now, why is this era so significant? Snowball Earth represents a turning point in Earth's history. Understanding this event helps us learn how our planet's climate can drastically change, and what might have triggered such extreme conditions. It also offers clues about Earth's early environment, and how life survived through such a challenging period. One of the most fascinating aspects of Snowball Earth is its impact on life. Despite the harsh, frozen conditions, some life forms managed to survive. Microbial life found refuge in small pockets of liquid water or beneath the ice sheets. These tiny organisms not only survived, but played a key role in Earth's eventual recovery from this icy catastrophe. In this video, we're going to explore how Earth entered this frozen state, the consequences for our planet, and how life managed to persist against all odds. By understanding Snowball Earth, we gain insight into both our planet's past and its potential future. How did Earth end up in a frozen state, so extreme that even the oceans were covered in ice? To understand Snowball Earth, we need to explore the forces that caused this global freeze. One major factor was tectonic shifts and continental drift. Millions of years ago, Earth's landmasses were positioned differently than they are today. Continents were clustered near the equator, which affected ocean circulation and heat distribution. As tectonic plates moved, they created conditions that led to cooling. This change in land and sea distribution altered the way heat was transferred across the planet, contributing to the onset of global glaciation. Another important cause was an imbalance in greenhouse gases. Greenhouse gases like carbon dioxide trap heat in the atmosphere, keeping Earth warm. But during the Snowball Earth period, it is believed that levels of these gases drastically dropped. This reduction could have been caused by several factors, including increased weathering of rocks. When continents drifted to tropical regions, rain eroded rocks, which chemically absorbed large amounts of carbon dioxide from the atmosphere, cooling the planet even further. A third factor is the albedo effect. Albedo refers to how much sunlight a surface reflects. Ice and snow have a very high albedo, meaning they reflect most of the sunlight back into space instead of absorbing it. As ice spread across Earth's surface, it increased the planet's albedo, causing even more cooling. This created a feedback loop, where more ice led to further cooling, which in turn allowed the ice sheets to expand even further. These forces, including tectonic shifts, a reduction in greenhouse gases, and the albedo effect, worked together to plunge Earth into a deep freeze. But how long did this frozen state last? And what were the consequences for the planet and its ecosystems? In the next section, we will dive deeper into what happened once Earth was fully encased in ice. Once Earth became fully encased in ice, the consequences were profound. Every ecosystem, from the deepest oceans to the highest mountains, was affected by this deep freeze. Let's start with the oceans. The oceans were not immune to the effects of Snowball Earth, with ice covering much of the surface. Ocean currents slowed down or stopped entirely. This affected the distribution of heat and nutrients, which had a direct impact on marine life. The chemistry of the oceans also changed, with less atmospheric carbon dioxide being absorbed. Ocean waters became more acidic. The combination of freezing temperatures and altered chemistry created extremely challenging conditions for life. So how did life survive during Snowball Earth? The frozen surface of the planet made it almost impossible for complex life to thrive. But some simple forms of life managed to hang on. Microbes, particularly those living in the oceans, found refuge in small pockets of liquid water under the ice or near hydrothermal vents. These microbes were able to survive because they were extremophiles, organisms that thrive in harsh environments. It is believed that life persisted in these isolated refuges for millions of years, despite the icy grip that held Earth. But not all life was so lucky. Many species, particularly those that required sunlight for photosynthesis, struggled or went extinct. The extreme conditions wiped out large portions of life, especially those organisms that were less adaptable. However, this mass extinction paved the way for new evolutionary paths. The survivors of Snowball Earth were better adapted to harsh conditions, and they would eventually lead to a dramatic increase in biodiversity once the ice began to melt. In the next section, we will explore how Earth eventually thawed out, and what this meant for the planet and its ecosystems. After millions of years in a deep freeze, Earth began to thaw, marking the end of the Snowball Earth era. But how did the planet escape from such extreme conditions? One of the key factors was volcanic activity. During Snowball Earth, volcanic eruptions continued to occur, even while much of the planet was frozen. These eruptions released large amounts of carbon dioxide into the atmosphere, slowly building up the levels of this greenhouse gas. With fewer plants and oceans to absorb the carbon dioxide, it accumulated over time, creating a thick layer in the atmosphere. This excess carbon dioxide began to trap heat, gradually warming the planet. As the planet warmed, the ice sheets started to melt. The process was slow at first, but as the ice receded, more of Earth's surface was exposed to sunlight. This reduced the albedo effect, allowing the planet to absorb more heat. Once this cycle began, it created a feedback loop in the opposite direction. Less ice meant more warming, which in turn accelerated the melting process. This warming phase brought Earth out of its icy prison, and led to a remarkable transformation. As the ice disappeared, the planet experienced dramatic changes in climate. Rainfall increased, and rivers began flowing again, carrying nutrients to the oceans. These nutrients fueled a burst of life, leading to the Cambrian explosion, a period of rapid evolutionary diversification. The melting of Snowball Earth did not just restore life on the planet. It set the stage for one of the most significant periods of biological growth in Earth's history. In the next section, we will explore whether a new Snowball Earth could happen again, and what modern science tells us about the planet's climate resilience. Now that we have explored the Snowball Earth era and its recovery, you might be wondering if something like this could happen again. Scientists have studied this question, and while another Snowball Earth is unlikely in the near future, some of the conditions that led to the ancient Ice Age are still relevant today. One of the most critical factors is the balance of greenhouse gases in the atmosphere. Just as a decrease in carbon dioxide levels helped trigger Snowball Earth, modern changes in greenhouse gases could significantly affect the planet's climate. However, Today we face the opposite problem. An increase in carbon dioxide levels is driving global warming rather than global cooling. So, what can we learn from the Snowball Earth era about our current climate challenges? One important lesson is that Earth's climate is capable of dramatic shifts. While Snowball Earth represents an extreme case, it shows us that even small changes in environmental conditions can lead to massive consequences for life on the planet. This history reminds us of how delicate the balance is, and why monitoring and managing greenhouse gas levels are so important today. Another lesson is that Earth is resilient, but recovery takes time. Snowball Earth lasted millions of years, and while the planet did eventually recover, it was a slow and painful process. Life was severely affected, with many species going extinct. This teaches us that while Earth may survive a major climate event, the impact on ecosystems and biodiversity can be devastating. We should not assume that recovery will be quick or easy. In the end, Snowball Earth serves as both a warning and a lesson in resilience. It shows us that while Earth has gone through extreme changes before, we should be careful not to trigger similar events in the future. The better we understand our planet's history, the more we can ensure a stable and livable environment for future generations. If you found this video helpful or interesting, please give it a thumbs up and subscribe to the channel.